All right, welcome to your third video for the Unit 5 covalent bonding unit. We've already done page 1, we've done page 2, and now we're on to page 3. So as a reminder for page, actually for the last 2.5 pages, the assignments that will be really important for you to review are going to be that lab on intermolecular forces and evaporation. So you should have some data in there that'll help you understand this one. So and also the other thing that will help you on this one is thinking about what we had for our demonstration that you glued into your notebook, which was this little mini demo on hexane, butanol, and methanol, where you had a different evaporation rate based on if something was polar or non-polar. So here we have the following molecules. We have the fastest and we have the slowest. The fastest one is going to be the one that is going to be the weakest. So our weakest one is going to be the fastest. So we're going to say that based on how we had on number 7 from video number 2. So the weakest is going to be the fastest. So then that would be number 1. Be our fastest. Number 2 would be the thing with the second strongest, or the second weakest intermolecular forces. Then 3 would be nonanol, because it's not as strong as decanol, but it's stronger than decane. And then 4 would be the slowest, because it's the strongest. All right, and number 9 I had mentioned, we'll talk about this, but really the gist of this is you got a triple bond. The triple bond means it's going to be stronger. It's going to be having a lower boiling point. It's going to be not evaporate as quickly as oxygen. So, which you'll see on number 9 here. All right, so then I'm moving down to your level 3 long-term learning target, where you can say, I can predict properties of a substance based on its molecular structure and support these predictions with experimental data. I have experimental data, and I'm going to share that information with you. So number 10, that is actually going to be the one that really helps you on, is this, again, looking back to what we had. We had hexane, butanol, and methane. Looking at the data that we have, remembering that little demo. So you're using the data above, indicate on the diagram on the left, rank the following substance from 1 to 3. 1 is evaporate first, 3 is evaporate last. So we've got hexane, butanol, and methanol. Hexane, please notice, we have a very large delta T. We have a very large change in temperature. Butanol, we have a small delta T, change in temperature, and here we have a large. So the largest delta T, as a reminder, the largest change in temperature is going to give us the quickest evaporation. So then we've got hexane is going to be number 1. Then methanol would be number 2, and butanol would be number 3. That's what I'm looking for number 10. So number 11 says to explain the difference in delta T values of hexane and butanol based on their intermolecular forces. So here we have, again, we've got hexane, we've got butanol, we've got hexane. We have a large delta T, and remembering that delta T, this means change in temp. A large change in temperature means that it is a weak molecule. A small change in temperature means that it's going to be a stronger molecule. So if I come back then to here, noticing what's going on with that molecular structure, the molecular formula and the molecular structure. So this one right here, this should tell you that there is hydrogen bonding. You got a hydrogen attached to an oxygen, so the hydrogen would then be that hydrogen bonding, essentially end of the day on a Friday, so not to let that fool you. So that hydrogen bonding makes that, like I said, a superhero molecule. It's going to make it super strong. Then we've got hexane. That hexane is then not as strong. So the delta T of hexane is so large because it does not have hydrogen bonding. excuse me, as I should have made that capital. And I could say then the delta T of butanol is so small. Oops, excuse me, that should have said should not have, does not have, should, because it has hydrogen bonding. So that would, oh my goodness, silly me. I'm so sorry. There we go. That, how embarrassing. Ah. So again, so the delta T of hexane is so large because it does not have hydrogen bonding. Delta T of butanol is so small because it has hydrogen bonding. All right, so number 12, it says, which of the alcohol studies has the strongest intermolecular forces of attraction, the weakest and then the weakest, and explain using the results of the experiment. Again, we're looking at that change in the temperature up here. We've got methanol, butanol, propanol, alcohol, ethanol. Those are all of our alcohols. We're not looking at alkanes right now. So we got these 4 alcohols. That means we need to look at our change in temperature. So number 12 says, which of the alcohols has the strongest? That means, as a reminder, you have a very low change in temperature. That means it's a very stable molecule. It's not going to evaporate as fast. It's not going to stay together. It's going to be super strong. Those intermolecular forces holding those atoms together, holding those molecules together is going to make it a stronger molecule. So if we have, we have the strongest, all right, the strongest alcohol is butanol, as it has, has the smallest change in temp. And then methanol has the weakest intermolecular forces, as it has the largest change in temperature. All right, got some folks knocking on the door. I need to head off to a meeting, but then I'll make that 4th video and you'll probably already see it on my website. All right, again, let me know if you have any questions, and you've got number 4 to page 4, and then especially if you're going for a 4. All right, have a good day. Talk to you soon. Bye.